So if the Earth had a second moon orbiting twice as far away, how long would it take for that moon to go all the way around the Earth? So if I have the Earth, like this, and then I have the moon, and let's say, so this distance here is 384,000 kilometers, and it's going around. Okay. And so it's going around the Earth, and then we have our second moon twice as far away, so it's out here, say. All right, and it's going around. Okay. And the question is, how long does it take for it to go all the way around once? And that's the period of the orbit. So the period of this orbit, we don't know. We do know the semi-major axis would be twice the 384,000 kilometers. And we know the total mass, which is really the mass of this moon and that moon and the Earth. And since the Earth is so much more massive, we're going to take the total mass to be the mass of the Earth itself, which is about 6 times 10 to the 24 kilograms. We have enough now to use Kepler's law. And with Kepler's law, we see that the period squared, measured in days, is equal to a cubed, measured in kilometers, over the total mass, measured in kilograms, times 7.9 times 10 to the 10, and then the units with the kilogram day squared per kilometer cubed. Okay, putting in what we know, we have the 2 times the 384,000 kilometers. We're going to cube that. We have a 6 times 10 to the 24 kilograms. And then we have the 7.9 times 10 to the 10 kilogram days squared per kilometer cubed. Now notice I'm putting in the units, and I always put in the units because that tells me things. For example, when I calculate 2 times 384,000 and I cube it and I divide by 6 times 10 to the 24 and I multiply by 7.9, what I get is I get a value of 5,964. But let's look at what the units are. The kilogram cancels with the kilogram. The kilometer cubed cancels with the kilometer cubed, and I'm left with day squared. So this is in day squared, and it's the period squared. So if I want the period, I need to take the square root of that. So I get the square root of 5,964 day squared. I'll take the square root of that. That's simply the square root of 5,964, which is about 77. And square root of day squared is days. So we have about 77 days. Compare that to our moon, which takes about 28 days or so to go around. This new moon, which is twice as far away, takes longer, but takes longer than twice as long as a month. So it takes more than 2 months to go around because it's actually moving slower. And that's one of the consequences of Kepler's law.